This is the second part of the lesson on section 7.2. We did evaluations on the first part of the lesson. We're going to do proofs or verifications on the second part. Now, we've already done proofs on the previous section. We're going to take the same format. We're going to start off on one side and end up with the other side. The only difference is that you'll probably find this a little bit easier than we did when we were doing fundamental identities to do our proofs. Let's look at number 26. Now, on the previous section, I think you liked these problems, the proofs. I think you liked them better than you did the regular problems we had before it. And I think you're going to like these better than you did the evaluations. Reason being, we already know the answer. The answer is sine x. We know that before we ever start. As a matter of fact, we even know what the last step is going to be. It's going to be sine x, and we're going to use three little lines, sine x. This is like therefore. When I work this down, I get sine x. Therefore, it's equal to this because we worked it down and found that it was that. Now, in order to do that, we're going to go ahead and plug this into difference of cosines. Again, I want you to look at your deal. I see that it's your formula sheet, and we see that we have cosine of a difference, which would be cosine of x minus y. In this particular case, we've got cosine of x, and we have cosine of y, which would be pi halves, plus sine of x, sine of y. All right, I've got cosine of x times cosine of pi halves. Cosine of pi halves, again, there's multiple ways we can do it. You can do it in your head if you think of your graph. We see that at pi halves, we would have 0 plus sine x, sine of pi halves again. Now, sine of pi halves, I think of my graph, and I know that it's 1. Multiple ways I can do that. I think of when I do it, I think of the graph, and I've got the answer real quick in my head. Of course, we know that, well, we just did the cosine graph a while ago. Let me talk about the sine graph just a minute to make sure we're all on the same page. If I do my sine graph, I know here at pi halves that I've got 1 for my y value. So in my head, I can do that without having to do any work. Anything times 0 is 0, so I've got 0 plus sine x. 1 times sine x is sine x. So this turns out to be sine x, and of course we knew that we were trying to get to show that that was sine x. So we have this proven. Some books say we have it verified. Okay, let's keep going and do another problem. And let's do problem number 32. Let's make sure I have it right. Cosine of x plus pi thirds, sine of x minus pi sixth. Now again, we already know the answer before we start. We already know that the last step on this thing is going to be 0 equals 0. So we know that. We're just a matter of getting from here to there. So here we go. The first one is cosine of sum. Cosine of sum would be cosine x, cosine of pi thirds, minus sine x, sine of pi thirds, plus. And then we've got sine of a difference. So we look on here at sine of a difference, and we see we have sine x, cosine of y, minus cosine of x, and sine of y. like so. All right, and we're going to evaluate that, and I'm going to write my two triangles back up here again. 1, 2, square root of 3. I'll just do the radians. This is pi sixths, and this is pi thirds. And we have our 45 degree right triangle, 1, 1, square root of 2. Pi fourths, because we only need this one, but I wrote both of them, wasn't thinking. Here we go. I've got cosine of x times cosine of pi thirds. Cosine of pi thirds. Cosine is adjacent over hypotenuse. That gives me 1/2. Minus sine x times sine of pi thirds. Sine of pi thirds, that's opposite over hypotenuse. That gives me the square root of 3 over 2. Plus sine x cosine of pi sixths. Cosine of pi sixths, that's adjacent over hypotenuse. That would be the square root of 3 over 2. Minus cosine x times sine of pi sixths. Sine of pi sixths, that's opposite over hypotenuse. That would be 1/2. I've got 1/2 cosine of x, and I've got negative 1/2 cosine of x, and if I add those together, they add out. I've got negative the square root of 3 over 2 times sine x. I have positive the square root of 3 over 2 times sine x. They add out, which leaves me 0 on this side, and certainly 0 is equal to 0, and we have it proven, or we have it verified, depending on which book that we're talking about. Okay, that concludes the section that we're on. Work those problems again. If you have trouble, then you're going to give me the problem number, and you will correspond with me over Google Classroom. Guys, again, and you'll get tired of me saying this, you guys take care of yourself. Stay out of crowds, keep your hands washed, don't shake hands with people, use hand sanitizer. You guys be safe, and we'll be talking to you when we hit the next lesson.